Alright, so welcome to the third episode of the series I'm doing on learning Ethereum from the very beginning. And so as I said, I'm kind of picking this up as I go along to some extent. I know which direction we're going, but I'm really trying to put this stuff out there as I learn it, so that you get to learn it as I do. So in the first couple of videos, we've covered the installation of Geth, which is the client that we're going to use to run our Ethereum nodes. And then in the second episode, we looked at setting up a local network of Geth nodes, and just to kind of get the environment set up and ready to have some fun. So in today's episode, I'm going to talk about how to install and run your very first Ethereum smart contract using the Solidity, the browser-solidity function, which is one of the ways you can compile smart contracts and deploy them onto your local Geth nodes, right? And have the smart contracts run. So the contracts in Ethereum, you might have heard of Solidity. Solidity is a language in which the smart contracts are written, and they're compiled and deployed to the blockchain, and that compiled code runs in the blockchain. So what we have to do is we have to find a way and have an environment to actually write that code, and then a way to compile it and then deploy it onto the blockchain. So we're going to use this browser-solidity, which is a completely free browser-based tool, which we're going to use to compile our contracts. So the first thing we're going to do, so I'm going to put all the links down below, but the URL is up here. I'm going to paste that down there. So we go to this URL, and this is the GitHub page for browser-solidity. So what we do is we go down here, and then we're going to download this zip file, right? So if I just click this, and then we do download, that's going to disappear to my downloads folder. So in my downloads folder, I'm going to copy this folder that I just downloaded, and I'm going to put it somewhere on, let's just dump it somewhere on the, just put it somewhere there, right? I'm going to open this folder, and what I'm going to do is I'm going to just open index.html. So what I've just done is I've just downloaded a zip file of this JavaScript based package, which runs in the browser, but it's completely local, so it's completely offline, so I don't need to be connected to the internet or anything to actually run this. Which is a great thing, right? I've got all the code I need, all the tools I need to basically work offline, right? So that's a great thing. So now I just have to save. So this is the path to this file, and all I have to do is make sure that I save a shortcut to that to this URL up here, the local URL, and then I've got the tool, right? So on the left hand side. So it's fairly simple. The left-hand side is the window in which we have. The left-hand side is the window where we have our actual Solidity code, right? And on the right-hand side, we have the essentially the compilation output. And we'll go over some of this in a second, right? Excuse me. So what we're going to do is we're going to go over to the left and hit this button here for a new file, right? And this is going to open a completely new, so there's some locally cached contracts here, so we're not going to worry about that. If you do this from scratch, you won't have these other tabs, but that's fine. We're just going to use this new tab, right? So we're just going to paste this code, and I'll put the again I'll put the actual this stuff in the comments, so you can actually copy and paste it in. This is not very nicely formatted, but don't worry too much about that. This is a very, very simple example. I'm not going to talk too much about the syntax of Solidity. It's not dissimilar to Java. The idea is you've got this is a contract, right? What we've got here, and what we're doing is defining a template. This is a bit like a Java class, and each contract of type greeter is going to have a string variable called greeting, and it's going to have functions to get that greeting, right? So we could just call it greet, and let's just get rid of that. And then I've just put an example down here of another function which we'll understand why I've put that there in a second. But this is a function which takes a string and returns the SHA-256 of that string. So it's just a simple computation on that string. And I'm also going to add another function called setGreeting. So we have a function called greet, which returns the current greeting of that belongs to this contract, and then another function which actually sets the value of greeting inside the contract. This is called a variable, right? This is part of the state of the contract, and you hear the word state a lot in Ethereum. Okay, so what we're going to do now is we are going to look over to the right hand side, right? So notice because I've got this auto compile ticked over here, then if I just put some nonsense here, then because the browser is recompiling on every keystroke, then I can assume that as long as there's no red warnings over here, that the code is compiling successfully, right? So we've got a few things down here. I'll cover them as we get to them actually. So the bytecode is the compiled bytecode, which is actually going to get deployed to the blockchain. This we'll come to in a second. This is called the application binary interface, the ABI, which we'll use later to actually invoke these methods on the blockchain. So we'll come to that later. So what we have to do if we actually want to deploy a contract of type greeter to the blockchain, the first thing we have to do is to actually create an instance of it and send it to the blockchain. So what we're going to do now is I'm going to show you. So if we go to the this cube up here, right, of environment, if I set this to Web3 provider, and then I click OK, and then down here we have a URL, the endpoint, right? So right down here, what I'm doing is I'm going to connect my browser here. I'm going to connect it to my local Geth node, and I'm going to deploy the contract onto this node, so that it's going to be hopefully mined it's going to become a transaction which is going to be mined into a block on my local blockchain, which is running on this node, right? So let me just show you how you set up this node so that it can accept these incoming requests from the browser. So we're back at my terminal. So I've got the terminal open at the bottom of the screen. I've got the browser at the top. So hopefully we should be able to see everything we need. Right. In this particular example, I'm only going to run one local node for the time being. So in the last video we showed running two nodes. For the time being, we're just going to keep it simple and run one. Okay. So what I'm going to do, I'm going to start my Geth node, and if you remember the last video, we went through some of these parameters. You might remember the network ID, which we don't need for now because we only have one node for the time being. This is our data folder where our actual local copy of the blockchain for this node belongs, and then we've got some new parameters here. Okay, and I haven't added them before deliberately because we haven't needed them until now, but now we do need them. So we need these RPC flags. In particular, well, we need them all, but in particular of interest is this number here, which you'll see is the same port we have over here, right? Localhost 8545. So that has to be the same number as that, right? You also need this flag RPC cause domain, right? And you need to set that to with an asterisk. Other than that, it's pretty standard, right? This is what we've been using all along. So I'm just going to start this. So this is going to restart our Geth node, right? And this is this is a blockchain that was already there from the previous video. So I haven't reinitialized the block or anything. But what we're going to do is we're going to deploy an instance of this contract to my local blockchain, and then we're going to see it appear in a transaction, and then we can be sure that we've deployed the transaction from the browser into the blockchain, and everything's good. So first of all, be aware when you restart, and this has caused me a lot of pain, when you restart the node, right? When you restart the Geth node, make sure that you, in the browser, you click off, and then you click back on, and then you reconnect, right? That's quite important. If you don't do that, it won't work, right? So now I'm going to scroll down. Excuse me, my voice is a bit groggy. And here, so the important thing here is that we have an option here to create a new instance of this contract, right? So if I say, and you have to use double quotes always. So let's say, hi Bob, right? We're gonna when we click this create button, what's going to happen is that it's going to create an instance of this contract, and it's going to send it to the Geth instance running at this address, which is the one I've just created down here, right? So if I do this, right? So first of all, common gotcha, you got to make sure that you unlock your account, right? So I'm just going to do personal. Like this, enter the passphrase. So now the account's unlocked. So then, let's try this again. So let's just get rid of this, clear the noise. If I click create again. So now we're saying we have actually, we've deployed this contract to the blockchain in a transaction, and we're now waiting for that transaction to be actually mined into a block. Now, we've just started the node, we haven't started the mining, right? So if we do eth.block number, as I said, this is a blockchain that I've been running locally for a few days now. So there's quite a few blocks. We're just adding this one to the top of it, which is perfectly fine. And what we're going to do is we're going to say miner.start, right? We need to start mining. So let's see. If we do block number, and also if we do, okay, so now you can see, what's happened now is very interesting, right? So now we have a transaction cost. This is the cost, and we're going to come to this in later videos. Not today. This is just about getting the browser set up. But we have details about this particular contract that we've sent. Just to show you how the browser sort of develops, right? If I do another one, hi Jim, then again we're waiting for the transaction to be mined. This is creating a separate instance of this greeter contract on the blockchain, right? It'll take a few seconds to come back. You can see now, so we're now down here at 7142 blocks. If we do eth.pending transactions, we can see there's still this transaction down here. Okay, this transaction is what we've just submitted up here, right? And it's waiting for it to be mined. So eth.pending transactions gets you the list of local transactions on the local Geth node, which are waiting to be mined in the next block, right? And we still haven't done that yet. And still there, and you can see it still says waiting for the transaction to be mined. But while we're here, it's interesting to see. Let's expand, and I'm going to go more into detail about what's going on under the hood in later videos. But while we're waiting for this to be mined, this is what this particular Ethereum transaction looks like. This is a new contract going into the blockchain, and it has so the from address. The from address, by the way, is the default address on the local mining node that I'm running, right? So if I do eth.accounts 0, apologies, you can see this hash 3523 is the same as this one. So the way this works is when you submit the contract from the browser to the local host 8545, the from address in the transaction is the default account on that local address. Okay, so and then the input. This is interesting. The input is actually the bytecode, right, of the the contract. It's the code that we've compiled. If you see here 6060604523 and you see here 60605234. So this is actually the compiled code that we of our functionality that we programmed over here, and it appears in the input field in the Ethereum transaction, right? So it's really, I find it really helpful to look under the hood a little bit and figure out what these transactions look like, what goes into the different fields, right? Not going to talk about gas in too much, or if at all, in today's video, but that will probably will be the next one. And let's see, has this been mined yet? Okay, so pending transactions is now empty, which means that this transaction here that we were looking at has now been mined into a block. And if we go back to our browser up here, we can see that we actually have two greeters, right? We have this one, and then we have this one, right? So these bars here, and let's just hammer the point home by saying, hi Barbara, right? To get you familiar with what the user interface looks like over here, and the idea of the fact that this is the code over here. It's like the template for the contract, but we can deploy as many different instances of that contract as we want with different parameters, right? And these contracts, again, this is more of a technical setup video at this point, but I'm just trying to gently, pardon me, introduce the underlying concept around contracts and accounts and all those kind of things. So now you can start to see, okay, there are now three bars here, 3 rows, and you can expand. This one is expanded already. You can expand any one of these, right? So we have, so these correspond to all the contracts that we've deployed so far, right? Now, so if this was the most recent one that we deployed, right? So what we can do, if you see now, inside this expanded window, these are the functions of that we defined down here. So set greeting, greet, and calculate proof, right? So if you, for example, so each of these functions has a button here, and if there's a parameter for that function, then you can enter it down the side here. And if there's no parameter, then you just click the button. So if I click greet on this one, it's returned hi Bob, right? Interesting, right? If I click greet on this one, it returns hi Jim. And if I expand this one, it says hi Barbara, right? Notice how the message hi Barbara was already there, hi Jim was already there, and hi Bob was already there even before I hit greet. That's because this is a very important point, but I'm not going to go too much into it now. This greet method is known as a constant or a read-only method, which means that there's no way, by clicking this button and providing a parameter, there's no way that you can actually change the outcome of that function, because the name or the greeting, hi Bob, right, has already been set in that contract, and by calling the greet method, all you're doing is returning it. So that's, in that way, the browser is able in advance to know what the output's going to be. If however I ask, okay, let's run this SHA-256 hash function, and if we say, please can we see the SHA-256 hash of the string the cat sat on the mat, right? Obviously, the output of that function is not known until you actually specify what the parameter is, right? So that's why I have to click it, and then I see, okay, this is the output of the SHA-256 hash function for the cat sat on the mat, right? So you can do this in the browser window. You can test your functions. So what I want to show you is, so you can hit this as many times as you want, and notice notice, right, I'm going to stop the miner down here, right? Miner.stop. And notice how I can call this calculateProof method as many times as I want with different input strings, and there's no miner. There's no mining going on. There's nothing being sent to the blockchain, right? Because this is a function that does not alter the state of the contract, right? When I say the state of the contract, again, what I mean is the value inside the variables, the permanent variables that belong to the contract. In this case, there's only one, and it's greeting. So because there's no way this calculateProof function can change the greeting variable, right? Because all it's doing is doing a SHA-256 on the string you've passed in. Then I can calculate this as many times as I want, and it will give me the answer without needing to have a miner, right? But let me just clear some of these away, right? So basically, each time you call a method or a function, you'll see it appear in the stack down here, right? What if I do set greeting? So at the moment, the greeting is hi Bob. If I try and call set greeting, right, to hi Janice, right? And if I hit this, look what's happening over here. When I call this set greeting, it's going to set the greeting variable in this contract, okay, to hi Janice, okay? Now, the idea around Ethereum is that this contract, as in this particular one here, right, that currently says hi Bob, will have been circulated around the entire blockchain network, right? And every single node will have a copy of this contract, and it will also have the greeting hi Bob. And this is the beauty and the power of Ethereum, right? The contract with the state is identical in every single node, right? So if you think about it, if I want to change the greeting in this contract to hi Janice, that needs to be communicated around the entire blockchain, and every single node has to accept and process this set greeting internally on its own copy of the contract and update the greeting, right? So that's why if I try and do set greeting here, and there's no mining going on down here, I'm only running one node, there's only one miner. If I try hit set greeting, then I'm getting a message saying waiting for transaction to be mined. So if you remember, when we deployed the contract, a new contract, right? It's hi Bob, hi Jim, hi Barbara, right? Those also required transactions to be sent around the blockchain, and for those transactions to be mined into blocks on each node, in our case only one node. For these functions, greet and calculateProof, because they didn't require us to update the variable within our contract, and therefore there was no change to the state of the contract on our local node, it did not require mining to be happening, right? Because there's no transaction required. There's no there's no block mining required. In fact, there's no record of me hitting this greet method, right? Because there's no change to the blockchain. But with set greeting, because I'm requiring a change to the contract to be deployed around the entire blockchain, and that's just going to sit there until I start mining, right? So if I do eth.pending transactions down here, so I can see, oh wow, okay, so I've got another transaction. This is this transaction down here. This is the JSON format, right? Is the same one that's waiting to be mined here, right? I'm updating the message from hi Bob to hi Janice, right? And we're going to go into a second about what the input means right here, right? But effectively, you're seeing everything you need and everything every node on the blockchain needs to update its variable greeting to hi Janice is stored and encapsulated within this transaction. This transaction is going to be circulated around the whole blockchain. Again, in my case, it's only around one node because I'm running a private network with only one node. I could add extra nodes to this, and they would also be doing the same thing. And I'll do that in a second. Okay, so I'm going to start mining. Right. So miner.start. So now if I check the pending transactions, it's already been mined, right? It's already been mined. So back up here, if I hit the greet button, which is calling the greet function, which is returning the new greeting, wow, look, it's updated to hi Janice. But the key thing is, it was not updated. So the result of set greeting was not updated via the greet method until the transaction had been mined into a block, right? And only then was the state of the contract updated, right? So now that's pretty cool, and we can see some results down here about the transaction. So just to, I think you can probably stop now if you kind of get the drift, but I'd be interested to sort of give one more example to hammer the point home. I've just quickly, in 5 minutes, written another contract called adder, and I'm just going to very quickly go over it, the process from start to finish, and kind of hammer home some of the points. In the next video, I'm going to show us how to, so if you want to skip this, feel free to, but in the next video, we're going to show you how to actually grab hold of this ABI, this application binary interface, so that you can deploy the contract from here, from the browser, but you can actually call these functions, call the functions and manipulate the contracts from the Geth console itself, so that you really only use the browser as a sort of a starting point to actually deploy and compile the contract. Because once you do things in the console, things get a bit more interesting, and you can kind of explore more. All right, so if you want to stick around. This contract over here, I've called it adder, right? Very simple. I think it's worth watching if you're new to this, right? So remember we talked about state. A contract has a state. In this case, we have two variables, right? We have, let me get rid of person. We have one variable, I'm sorry. So we have one variable called name. So let's say this contract is an adder and it's going to have a name, right? Just like bunny, rabbit, or whatever. But this contract has a very simple function, which is to add two numbers A and B, right? So the function here couldn't be simpler. But there's one other function that you can call on this contract, which adds A and B, but also renames the contract to it renames the contract instance to whatever the name you supply, right? So if I just click, so clearly it's compiling okay. I'm going to click create here. So if I click create here, and I'm waiting for this to be mined. There you go. So it's empty, and you can see up here the contract is deployed to the blockchain at this address. I'm going to talk about what that means. Like, what does that mean? A contract is deployed at a certain address. We're going to get to that, but just to show you, just the process of calling these functions from the browser. So if I add, say, 2 and 4 and call add, then I get 6, right? int256 is just the data type. If I add 45 and 76, then I get 121, right? And notice there's no transactions. There's no transactions up here, right? I don't need the miner to be running, and the reason is because this function add A and B, return A plus B, is not changing any permanent variables in the contract. There's no lasting effect to calling this function in the contract. Therefore, I don't need to use it. I don't need to put it in a transaction and send it around the blockchain so that all the different nodes can update their own local copy of the contract, because there's no change to the contract. I'm just calling something. So that's a really important point. Read-only functions only execute on the node on which you're invoking them. That's a really important point. So people say, oh, contract code executes everywhere. Well, only for methods or functions which update the state of the blockchain. Otherwise, all that functionality, just it runs on the local node on which you're running, which presumably, so if you wanted to write a function here that sort of goes into an infinite loop, which a lot of people think, okay, this is really dodgy. You're writing code that runs on every single node in the blockchain. What if I could I could write a function here that goes into an infinite loop or something and brings the whole network down. Well, all you're going to do is bring your own. You're going to bring the local node down potentially, but that's the node on which you're actually running the contract yourself, and you kind of assume that you yourself would, because you have access to that node, you kind of have some level of ownership or responsibility over it. Okay, so that's a really important point. So set name. Let's call set name. So because at the moment get name is returning an empty string. If we call set name, let's call it bunny rabbit. Right, and we call set name. So again, we're waiting for the transaction to be mined. Why are we waiting for it to be mined? Because we are changing the name parameter of this contract, right? So therefore, we need a transaction, and we need to tell every node on the network, you need to process this transaction and basically update the variable called name. So that's come back now, and now if we call get name, we see okay, it's bunny rabbit. So we've successfully updated the name. So we've seen two functions there. One of them does not require a transaction, and one of them which does require a transaction, right? So guys, thanks for watching. If you got this far, I'm deliberately sort of not going into too much detail at the moment about what accounts and contracts really are. You might have heard about some of these things. This is really a sort of a gradual learning process where I'm also building my own familiarity with it as we go along. I just want you to kind of play around with the same steps that I do, and hopefully build familiarity this way. And some of the pain points I'm picking up, I'm hopefully explaining as we go along. If you're not familiar with blockchain at all, then I suggest you start. One way of doing it is to start with my Bitcoin videos, which have a fairly in-depth description of blockchain concepts. So in the next video, what we're going to do is we're going to explore calling these functions on the smart contract from the actual console window itself, right? Which is where I think the fun really starts, and you can start seeing the end-to-end workflow and really get a much better understanding of what's happening. So thanks for watching, and I'll see you next time.